The reason this is so powerful for our students that have any type of learning disability or any type of disconnect such as ADD and ADHD is it's accessible.
Hi, I'm Cheri here at Tier 1 Interventions Podcast. Today's episode was recorded about 2 years ago in an evening workshop that we did. I've taken an excerpt from that workshop and I want to share it with you tonight. The full episode you will get to know a little bit more about at the end of the podcast. So make sure you stick around to the end to find out how to learn more. For now, let's listen in and hear what Jonily is teaching about quick dots.
Cheri and I have been collaborating on her expertise, which is neuroscience and occupational therapy, my expertise, which is the mathematics. And what you're going to get tonight from us is not going to be content that you see on Saturday mornings if you come to Saturday Math, or if you've been a part of any of those opportunities that we've had. We are taking a deep dive into how to enhance the complexity of mathematics with our most struggling learners. Now, we're also focusing on students with disabilities, dyslexia, dysgraphia, and dyscalculia, and what the disconnect is in their brain, and how quick dots, and we'll tell you what a quick dot is, but if you've been around me, you know what a quick dot is, how quick dots will connect that disconnection in the brain through lots of the therapies that Cheri's going to teach you, and then enhance the mathematics that I'm going to show you tonight. We are excited to combine both of our expertise and bring to you a combination of what we both teach. And this is for K through 12, even preschool and higher ed. So we're going to extend the math all the way beyond. And I will also give you examples of how I use this mathematics with all of my levels, kindergarten through high school.
I bring in the neuroscience. Every time I look at the Purple X, all I see is the visual perception and the visual motor. It has been a journey to try and learn how to connect it to math. I had to slip this one in tonight. Just as I was getting ready to come upstairs to my computer, my husband flipped on Fox News after we were done with supper to this report that said, in Philadelphia, 23% of fourth graders are proficient in math and 29 are proficient in Chicago. That was on the Brett Baer show. I tried to look up the link, but because he was still live and online and didn't have a chance to take that anywhere else, that was what he said. I don't know where he got those statistics, but that's what my husband told me. I missed it, but that's what I was told tonight. But when you really think about that, 23% of fourth graders are proficient in math. What? All I gotta say is, what?
And I think if you look nationally, urban versus rural versus suburban, these, I'm assuming, are urban numbers. I don't know. I'm assuming these are urban numbers, and typically you get an average for suburban numbers and rural numbers. However, in any of the numbers, based on any reports that typically come out, we are not seeing steady increases in math over time. And as a matter of fact, there are inconsistencies in the increases and oftentimes decreases in the number of proficient based on a wide range of worldwide and national assessments. Obviously, you're here tonight. We have struggles in mathematics. I'll give you another statistic. Of students that have dyslexia, about 40% of those students could possibly have a math learning disability as well. Math learning disability being called dyscalculia. Dyscalculia research is 20 to 25 years behind where dyslexia is. So although we've made some gains in reading, there's still some controversy, and some gains with our dyslexia students, I don't even think we've hit the tip of where we need to be, and we definitely have not done that in mathematics. And I will say, until now, what Cheri and I have done together with our work has been leading the way for dyscalculia, specifically in this country, and we're hoping around the world. What you're going to hear tonight is very cutting edge, very new, and ahead of the curve. So very exciting for you to be here tonight. What I want to say to preface this evening is I myself have my own action research statistics from multiple projects I've done over the past 18 years. And in our statistics, I'll give you a couple of examples. With a sixth grade cohort group, we took them with the model that we're presenting to you tonight. We took those students in less than a year from 27% passing their fifth grade state math assessment to 60% passing the very next year and 92% showing growth. We saw a significant increase as they moved to seventh and eighth grade. It was a school that had a lot of transient students, but of the students that were still at the building, it was a title building, we saw a steady increase from the kids of that cohort. I also am a part of a recent project with current fifth graders that I have been using this model with since they've been in kindergarten. This has been an amazing project. And the data that we have on standardized tests is that this cohort of students has broken the bell curve. When you look at math achievement on a standardized assessment, you're looking at percentile rankings. 50th percentile is average. Of this cohort of students that started in kindergarten, the lowest percentile on the math portion of the standardized test was 71st percentile. Now, if you know anything about that, that is all on the far right side of the bell curve, past the peak of the bell curve. If you look at a bell curve, the peak of it, the center, is 50th percentile. So these students were all high achieving, but when you look at their cognitive ability scores ranged anywhere from 87 to a couple of them in the gifted range at 132, 141. This is exciting, action-based research. What we're going to share with you tonight is one of our interventions, and that is a quick dot. We have multiple types of interventions. Tonight, we're going to focus on the quick dot, and we want to know how to expose more mathematics out of these struggling students so that it becomes habitual and a way of life for them. We are just excited to bring this to you. If you've not seen a quick dot before, we're going to show you the next set of dots for about 4 seconds. We're going to show you in two different ways, one with the grid behind it, one without the grid, so 2 seconds each. And at the end, I want you to type in the chat, how many dots did you see?
Is everybody ready? Here we go.
How many dots did you see? The reason this is so powerful for our students that have any type of learning disability or any type of disconnect such as ADD and ADHD is it's accessible. One of the takeaways I want us to have by the end of today is I want mathematics to be accessible yet complex at the same time. It's very purposeful that I use the same quick dots over and over again. Because when we use the same task over again with multiple grade levels with the same students, that's how we're going to get our students with disabilities interactions over time. Our gifted students need 1 to 2 interactions before they have forever learning. They know it forever. Our bright kids who play the school game, they achieve well, but they're not necessarily identified as gifted, might need 5 to 7 interactions before they know it forever. And our students with disabilities and our struggling students, our at-risk students mathematically, might need 60 to 100 interactions. How do we get more interactions over time? By using the same quick dots again and again. Tonight, we're going to show how the complexity of mathematics can happen much earlier than middle school, specifically in first and second grade. You're going to be blown away a little bit with the mathematics. However, it's important that you understand the mathematics. You are telling me 72, you see the overlaps, you see the 3x3 grids. That is beautiful. One of the deficiencies for our students that have learning disabilities is the struggle with estimation and math facts. When we're facilitating a quick dot, you're going to do it exactly like I did. I'm going to show you this for 4 seconds, take it away. The reason you have these facilitation slides where the border is light is to remind you that at this point, you could do a turn and talk for students to talk to each other about how the dots were arranged. For all of you right now, go ahead and type in the chat. Kate already did this, but type in the chat how you saw the dots arranged. I want to share why this is so essential with students. We're not necessarily solving anything here. What we're doing here is we are extracting student perspective. Part of student motivation and engagement is about feeling a sense of belonging and feeling like I'm able to achieve. What an exercise like this does is changes the mindset. I don't have to teach fixed or growth mindset or whatever climate and culture I want to create in my classroom. I don't have to teach that. I can just provide a task that's going to give kids a sense of belonging, a sense that she cares what I think, a sense of accessibility. Most importantly, aside from the mathematics, we want to tap into those positive emotions. This reaches over into Cheri's expertise, which negative emotion hinders the ability to learn. The quick dot you saw was the image for stage 3. What we're going to show you now are images for stage 2. I get this question many times, and the question is, why don't you start with stage 2 with students with disabilities? Because there are fewer dots and it will be easier for them. I want to answer that in a couple of different ways because that's an important question. Number one, if we begin with something too trivial and students feel like they get it incorrect, then their mentality is, I can't even get the easy one. In my experience, delivering a more complex but easily accessible stimulus like this quick dot in stage 3, and especially if I'm giving this to a whole class of students and not just my students that I've pulled for intervention, I can naturally differentiate because with the complexity of stage 3, my gifted or higher level students really have equal access with my lower level students. If the higher level students are struggling with it, then look at the mentality shift that takes with our lower level students. Oh my gosh, Johnny always gets these problems, but this time Johnny wasn't quite sure. This is really cool because I may have guessed better than Johnny. This is a complete shift in prompting to level the playing field for all ability levels of students. And I can't stress that enough.
I love what Nicole puts in the chat. Some of my lower special education students get quick dots right away.
And Nicole, if you want to unmute and expand on that, I'll expand first, but I'd love to hear your testimony. Nicole is actually one of our certified coaches who has been heavily implementing. But the one thing I'll expand on Nicole's comment is that this changes the outcome of the game or the question of who's good at math. Because our students with disabilities are actually better in general than our higher achieving student with these specific quick dots. It completely changes where students position themselves mathematically within their cohort. Nicole, do you want to add on to that in your experience with your 8th graders?
I would say with my experience, it's because it's a visual. That's why so many of them catch on quicker than some of the, you could say, higher students.
Absolutely. There is a disadvantage for many of our high achieving students when we represent math visually. It's exactly what our students with disabilities need. However, it becomes a struggle for our high achieving students because what are those students good at? Those students are good at symbols and notations and mimicking and memorizing. When we change it to this visual aspect and make math visual first, we change who has the better access to it, and that is our students with disabilities. Great point, Nicole.
My daughter is a gifted student with a struggle in writing. She will tell you, I can do integrals and what's the other one? Integrals,
Derivatives.
Derivatives. Thank you. In my sleep, but don't ask me to add, subtract, multiply, and divide.
What I'm going to ask you to do is, and some of you have seen this before, and this is also purposeful. Some of you have not seen this before, and this is purposeful. I want to show you an analogy right now of how our students with disabilities intake and perceive mathematics and what a challenge it is to them. Because what I'm going to show you next is a visual, but it's not a connected visual. And I'm going to talk about what that means. This disconnect with students that struggle with pattern recognition and making connections, which gifted kids can do very naturally and innately and not even be able to explain how they're doing it. And it's absolutely brilliant. The way that our students with disabilities see mathematics is very disjoint, disconnected in our typical traditional delivery. And I'm going to show you what they feel right now. Now, if you are a mimicker and memorizer, you're going to do better on this exercise than if you are someone who doesn't mimic and memorize. We're going to show you 9 symbols. The 9 symbols are listed vertically, and they're in different orientations. We're going to show you these symbols for about 5 seconds. Once we take it away, we're going to ask you to write down the 9 symbols vertically in the same order and the same orientation. So don't write until the slide comes up that says write and we take away the images. So in whatever brain capabilities you have, whether it's seeing patterns, making connections, or just simply memorizing, I want you to use the strengths of your abilities to remember as many as you can. And then once the slide is taken away, there'll be a slide. Go ahead and write down those 9 symbols in the same order, in the same orientation that you saw them. I have to tell you a story before I have you check your work. I was doing a professional development a couple of years ago, and there was a teacher that had been in a professional development of mine 8 years prior. I had done this exercise, and I was relating it to something a little different because the topic of the professional development was a little different. After I showed this, he got all 9 correct. I didn't remember exactly who he was, but at the end when we were sharing, he reminded me that he was in a professional development 7 or 8 years prior. I had done this exercise. He hadn't had any interaction with me since. He hadn't seen me anytime since and got all 9 correct because of the connection that I made in the delivery of my instruction when I did this with his group 8 years prior. What I want you to absorb is that when we can explicitly and directly create mathematical experiences that are visual and help students recognize patterns and make connections, because students with disabilities have a disconnect with recognizing and using patterns, which is why they sometimes make the same mistakes or the same core behaviors over and over again. They're not understanding the connection of whatever consequence it was. They truly don't remember and relate and aren't able to see their own patterns of behavior and how that's negatively affecting the interactions with other students and adults. Pattern recognition is extremely important, and it's one of the things that students with disabilities lack. So not only with soft skills or social skills do we want students to improve their pattern recognition, we also want them to be able to do that mathematically, so that carries over to socially, and quick dots again is one of the ways to do that. Let's check our work. I want you to type in the chat how many you have the correct orientation and the correct position. I'm going to show you the alternative in how to deliver and instruct mathematics and how students can perceive the connections and the recognizing of patterns. And this is exactly why this person that I told the story about that remembered these symbols, this teacher, had no interaction, had no studying, had seen this one time and retained it forever. Now, I did ask him, the first time you did it, how many did you get correct? And he said 3. What I want us to think about is, how do we deliver instruction mathematically so that kids don't have to mimic and memorize? They could if that's their skill. Like many of our high-achieving math kids, they have a great ability and skill to mimic and memorize. And I do not want to take that away from them. That's how I got through math. I was able to mimic and memorize, and I was high-achieving. Now, later on, I found out I knew nothing about mathematics or numbers. However, I was able to achieve high because I was able to mimic and memorize. But how do we deliver instructional experiences mathematically for students so they don't have to remember, they don't have to mimic, they don't have to memorize? They'll just know it. It'll be ingrained and become an innate part of their understanding. And that's the question that we're going to answer for you tonight.
We have 2 comments. They're saying that they remembered all 9 because they've done this with you before. I wanted to ask Debbie to unmute. And can you relate to the story that Jonily just expressed? Is that how you remembered this? Or was there something else that happened that helped you recall this task?
Did you see this with me?
I want to say 3 or 4.
How about you, Nicole?
I only can remember 1, even though I have seen this before. My brain is mush.
I love the examples that we have here with previous interactions and not previous interactions. I'd like to hear from someone who has not seen this with me before.
I'm going to go with Beverly.
I have not seen this before. I was, in the few seconds that we had, I was trying to figure out a pattern, but I really only got 2 correct there. I'm looking forward to finding out what the mystery is, how to solve this.
I was the same way, Beverly. I'd never seen this before either, and I was able to do the first 2 and the last 2, and I had no idea how to connect the rest of them. I can do things so long, I can't.
What I love about this is almost all of you have had interactions with me before and my teaching, but at different phases. What I mean by that is some of you are recent in the last year or 2. Some of you, it's been 2 to 3 years. Some of you, it's been 4 to 5 years. Some of you, it's been 7 to 8 years since we have had some major interaction. What I'm delivering to you has been the most essential and most impactful and most powerful impact for students with disabilities. But at this point, everything that I've done that has not been impactful has been filtered out. And what you're seeing tonight is the evolution of what sticks, just to make that point. I think if you guys walk away with nothing else, it is to not start with the most trivial example. Because when students can't even do the easiest one, and we don't even have to say it. I can put something up there that looks simple, but say, oh, this is a tricky one, like I'm trying to insult their intelligence. They know when things are trivial and when they're complex, because your frequent flyers in the classroom that are always answering every question are going to be able to do it. When that happens, that's when students with disabilities internalize, gosh, if I can't even do the easy one. So we might as well do the complex one so that, gosh, I couldn't do that, but she told us that was really difficult, and I believe her that it was really difficult. And I think that is a counterintuitive approach to delivering mathematics instruction that has been a game changer. I think it also is counterintuitive for the research that we have seen in special education. Let me talk about that for just a moment. All of the facilitation and instructional guidance that I'm giving you is based on improving student number sense and conceptual understanding. Number sense is defined as the innate intuitive understanding of number or the size of number. It's inborn and it's common sense. But I don't want to say common sense in the fact that everybody has it. It's a common sense meaning if you have it and if you don't. Number sense cannot be explicitly taught, but it can be learned through experiences. All of the special education research concludes that students with disabilities need explicit direct instruction in mathematics to close gaps. However, in all of that research, it is based on the opposite of what I've just described, the opposite of improving number sense and the opposite of improving conceptual understanding. The explicit direct instruction for special ed students using line paper, grid paper to line up numbers, et cetera, all of the research has only been done on the procedural and fact-based efforts of mathematics. I completely agree with that. If we're teaching the long division algorithm, or we're teaching subtraction with stacking and regrouping, if we're teaching solving linear equations, if we're teaching solving proportions, whatever the content is, whatever the skill is, if it's a procedure that we're teaching, then students do need direct, explicit instruction. I don't want them to create that procedure. Here are the steps. Here's how to do it. Now try a few. That has typically been 100% of what we teach in mathematics and 100% of what we put on IEP goals. But if we want to improve the procedural and the fact-based abilities mathematically, we will gain more leverage in improving the procedures and the facts if we at the same time improve conceptual and number sense. So I want to state that tonight, I'm not focused on the procedures. I am going to be focused on the facts later. I am focused on facilitation strategies to create experiences in which number sense and conceptual thinking.
Today's episode of Tier 1 Interventions was brought to you by Disability Labs. One of the courses that they have contained in Disability Labs is the Purple X mini course. Click on the link in the show notes, and if you want to know the answer to that symbol, also click in the show notes and download the Purple X mini course today. I'm Cheri Dutterer, one of your co-hosts here at Tier 1 Interventions Podcast.